Welcome, everyone. We have a full house tonight. It's really a pleasure. I will just introduce the structure of this roundtable. We will explain you what is DNSSEC, so how to secure, how to be sure that when we go to destination with a domain name, we are going to the legitimate destination and not to something hacked bad. And we have different experts that will explain you that from the SSAC, the Security and Stability Advisory Committee of ICANN, and with different perspective. The end users also with showing of some tools. In the second part, we will talk about the different implementation and then also to have testimonials moderated by Natalia Filina. And you will see we have really some countries really fun and doing it much and some others not at all. I would like to show, by the way, the map of the use of DNSSEC, and you can see that some countries like Iceland is about 100% of validations made with DNSSEC, and some other countries, and we have someone from Portugal, it's less than 10%. Why do we have so many differences? And to know who you are, what the level of knowledge we have a short poll we have now before starting. Okay, thank you. So the result, I see many people that have only heard about DNSSEC and mostly positive. Some are rather mixed. And and for people who have implemented, we have different perspectives. And only a few people never heard about DNSSEC. So it's quite positive, but the purpose here tonight will be to drop the statistics to have really something really positive. Matthias, the floor is yours. Why DNSSEC, please? Go. Thank you.
Hello, everyone. My name is Matthias Rodobnik. As Fredrik already said, I serve as the ALAC liaison to the SSAC, and I'm also an SSAC member. And my goal today is to pull back the curtain on how DNSSEC actually works in practice a bit, to give you an intro, and where it helps and where it has the limits. As we know, the DNS is the phone book of the internet, but it was designed, let's say, in a friendlier time. And today we need to ensure that the answers we get from this phone book are the real ones, or at least that we can detect when something is wrong. Please, the next slide. Think of a standard DNS query, so like an unsealed postcard. So it's sent in the clear. Anyone along the route can read it, or worse, erase the address and write a new one, for example, and sending you to a malicious site instead of your bank, for example. And the digital seal, let's say, the domain name system security extensions adds a digital seal to the postcard. It doesn't hide the message. There is no encryption, but it allows your resolver to see if the answer was tampered with and blocked forged responses. And the core goal is the two key benefits, let's say, are the origin authentication, knowing the answer came from the right source. And the second thing is data integrity. So knowing it wasn't modified along the way. To the technical core, so at its heart, DNSSEC uses public key cryptography. The zone owner has a private key to sign their DNS records. And this creates what we call an RSEC, resource record signature, which is essentially a digital stamp. And then with a verification process, they also publish a DNS key, so the public key. And when your resolver receives a DNS answer, it uses this public key to verify the signature. And if the signature is valid, the data is authentic. If not, it's rejected. And the protection only works when the zone is signed correctly and the resolver is doing DNSSEC validation, which is still not universal on today's internet, that we also saw on the map of Fredrik before. So the chain of trust. The problem is, how do we know that the public key itself is legitimate? So an attacker could publish a fake key. This is where the chain of trust comes in. So your resolver starts from a built-in trusted key for the root, follows DNS records through the hierarchy, and only then decides whether to trust the final answer. So the hierarchy itself, the DNS has a natural hierarchy. Each parent zone vouches for its child. And the parent stores a hash of the child's key called the DS, or delegation signer record. And the chain itself, this creates an, let's say, unbroken chain from your domain up to the TLD, like or .com. And finally, to the root zone, key is the trusted anchor, the starting point of trust for the entire global DNS. So then also providing a kind of negative example. So the challenge is one clever part of DNSSEC is how it handles things that doesn't or don't exist. So in standard DNS, a hacker could forge a not found message and redirect you elsewhere. So, and the solution is that DNSSEC uses special records called NSEC or NSEC3 records to provide signed proof that a name doesn't exist. It's notarized document saying there is nothing between, for example, entry A and entry C. And the trade-off is that depending on how they are configured, these records can also make it easier to see which names do exist in a zone. A bit like to the user experience and invisible protection. So for end users, this is almost entirely invisible. So you do not need to install a DNSSEC app or something like that. Your recursive resolver, usually provided by your ISP or a public service like Cloudflare or Google, does the checks for you. What happens on failure? So if validation fails, the resolver won't show you the fake site. Instead, it would return a server fail. While it might look like a broken link, it's actually your silent bodyguard preventing, let's say, a hijacking attempt, or sometimes just a sign that someone misconfigured also the DNSSEC for that domain. Then this brings me to my last slide. In short, what is very important, DNSSEC provides what I said at the beginning, two things which are very important: the origin authentication and data integrity. So it helps make the internet foundation more trustworthy, where it is deployed and maintained correctly, which is also important. It does not encrypt your traffic. It does not block all phishing or malware by itself. And if it's set up badly, it can even take a perfectly legitimate site offline. It's a powerful tool, but not magic. And now I will take this further and give the word to Peter, and he will give you a bit more practical insights. Thank you very much.
Thank you very much, Matthias, for this nice introduction. So we'll hear now Peter Thomassen, also from the SSAC, who will explain you, can DNSSEC be like a car airbag? And
Exactly.
show you the new developments and remake it. Peter, the floor is yours.
Hi, exactly. Hello, my name is Peter Thomassen. Matthias has nicely explained what DNSSEC is and how it works. And I will now talk about what the domain owner actually has to do to turn it on for their domain. And I'm sure there is things everybody has heard that it's quite complicated to set up. And it's actually true that it has been complicated in the past, lots of manual interactions. And the question is, couldn't it be like a car airbag, right? You buy a car, the airbag is just there. You don't need an app. You don't need to turn it on. So let's see. We have seen, I think, some numbers before about the DNSSEC validation deployment in different countries. The numbers here on this slide are about how many domains actually have signatures, because if they don't have signatures, you also cannot validate them. It turns out globally, 7% of domains have DNSSEC, and that's not very much. Depending how you look, for example, if you look in the top 1,000 domains, the most used ones, it's around 20%. And then in some countries, which give incentives like discounts to registrars in the Netherlands and Sweden, it's 50 to 70% for some TLDs. However, if you are a DNS operator, for example, and your customer turns on DNSSEC, signatures are produced and everything, you can investigate whether the DS record that establishes the chain of trust is actually configured by the domain owner. And it turns out that's only the case in roughly half of the attempts, right? So the customer tries to turn on DNSSEC, and then in roughly half of the cases doesn't follow up correctly to configure the chain of trust. Now, why is that? And is DNSSEC too hard? And is it maybe too scary? People are afraid maybe, or the thing is, it is actually really hard. There's different web interfaces to put the DS record there. This is one web interface from one registrar. You just have to paste the whole DS record into it. So the DNS operator like Cloudflare has to give it to you. However, the interface from the registrar where you do this might also look like this with different fields, and it has private and public and key type, things like ZSK, key tag, who knows what that is. And then it might even look differently like this one with max signature life and flags and who knows what, right? So the whole thing can be done in different formats. And that's very confusing because the DNS operator that gives you the DNSSEC information to configure with the registrar, they don't know what the format the registrar is. So there is all kinds of information and then you don't know what you need. And this is actually an accessibility problem. The main point I'm trying to make in the first half of this presentation is not that DNSSEC is hard. It's not hard. It is actually automatable. It is possible to do it correctly, but usually it is not accessible. So what we're trying to do is to make it more accessible by using automation. So closing the accessibility gap through automation is what we think the goal should be for DNSSEC. And it doesn't only make DNSSEC more accessible, it also reduces the chance for error, because if it's automatic, then you don't have to copy and paste things and type cryptographic strings. That doesn't mean that everybody has to have DNSSEC. The automation just means if you go to your DNS provider and you book a package that has DNSSEC, then you automatically have it without doing anything else. It doesn't mean that everybody has to book a DNSSEC package. In this case, no manual intervention is required. And the way it works is that there are special records that the DNS operator puts into your child zone. And then those are used as a signal that the registry can see to determine that the child wants DNSSEC to be turned on. So essentially, for example, example.se talks to the .sweden registry and says, look, here's my cryptographically proven request. I want to enable DNSSEC. This is my DS record. And then there is some cryptographic stuff in the background. And so this is called DNSSEC bootstrapping. And it actually works. It's been deployed by some top-level domains. And then in the second step, the registry will ingest this request and think, okay, I can verify this. I put in the DS record now. But the point is you don't have to go through any forms. The implementation status of this is that some CCTLDs have implemented this, for example, .ch. Olli Schacher will talk about this in a bit. But unfortunately, it is currently not possible for GTLDs to implement this. And the reason for this is that ICANN does not approve of that for good reasons, because there are some minor implementation differences in the automation. For example, if a domain registration has a lock, like an update lock, then the question is, should the DNSSEC automation maintenance, for example, to update the keys and all of that, should that continue or should that be blocked by the registration locks? And so ICANN.org would like these things to be reconciled and figured out before they would allow GTLDs to deploy this. And this is in a way a blocker, but it's a good blocker because if you have a big domain portfolio with many TLPs, then it's better if you're not surprised because things work equally everywhere. And in the SSEC and at the IETF and the DNS working group, we've been working on developing uniform guidance to solve this problem across the TLD space. I think on the next slide, I have a number of technical references. I will not go into that in detail. It's just if you want to read more about it, you can do that later when you download the slides. So there's two central RFCs. The RFC 9615 is the automatic DNSSEC bootstrapping method from roughly 1.5 years ago. That's what I just explained, where they talk to each other. And the second document here is these uniform guidance recommendations that I mentioned on the previous slide. And they are almost finalized and it will probably be an RFC later this year. And then the other RFCs here are related to technical content. All right, so I think it's about demo time. It would be nice, I think, if I could demonstrate to you how this automation feels from a domain owner perspective. So what I'll do is I will register a domain name without enabling DNSSEC. And then I will create that domain name also in a DNS hosting platform, which is called DESEC, which happens to be operated by us. And we support all the automation stuff. So we publish the special records for the DNSSEC bootstrapping. And then later in this webinar, we can come back and check whether it has worked. Now, actually, normally this happens like at 3 in the morning in the night or something. So I will pull some levers to speed it up a little. But the point is the experience you'll see will be the real experience you would have as a domain owner. All right. So this is a registration form for domains at a registrar. And let's say we register uralo webinar.cz for the Czech Republic. And so we'll do that for 1 year period. And then, okay, so the registrant will be myself, Peter Thompson from DESEC. Okay, you can watch this 2 more times because I have to provide a technical and an administrative contact, which will be the same, Peter Thompson. It's almost done. Okay, so I need to specify a name server. So I will use ns1.desec.io and ns2.desec.org, which is our name servers, and create the domain. Okay, so this has now been registered. And now I go to the DESEC web interface, which is where the DNS records can be configured. You got password manager for that. So this is what you would do if you were going to configure your email server records or your IP address records or something. Okay, so this is the see all my passwords in encrypted form. And so let's log in. And I'm also creating this domain here. What did I say? It was uralo-webinar.cz. So let's do that too. uralo-webinar.cz. Okay. All right, so that has been configured. And let's just create some random text record or something, okay, so that we can later check it. So we use a text record. And maybe the content could be something like, hello. Okay. So this will all be published now, and the domain is registered. It's not yet visible because it takes a few minutes to register domain name. So actually we can check uralo-webinar.cz at the DNSSEC analyzer, where you can check DNSSEC status, and you will see the domain is not registered yet. It's not in the CZ zone yet. But later when we come back, we can check, and we will see in a bit once it's visible that it doesn't have DNSSEC enabled yet. And then a little later, we will see that it is. With that, I'll give it back to, I guess, Frederick or Julian. Thank you.
Thank you very much, Peter, for your explanations and for this demo. And before going to the next point, we'll have a second short poll to know if you have implemented in the audience yourself DNSSEC. Yeah, so we see that there is about a half have implemented DNSSEC for one of their domains. So we have already a good proportion there. And then, yeah, a third that's who didn't. And a few ones they don't know or they don't have a domain. So we have really a good audience here tonight. And the purpose is to convince all the rest and of the end user perspective. Julie, the floor is yours.
So for my part, I will talk about the DNSSEC, but from the end user perspective, as Frederick just introduced. So basically the idea is how end user can get access to this DNSSEC information, but in a really easy and intelligible way. So that will be the most technical slide for my presentation. But basically how we can get the DNSSEC information, we can get it from the first party or the third party. For the first party is basically just verifying the whole DNSSEC chain. But for that, the main disadvantages is that it's CPU network intensive because you need to cryptographically verify all the links. And also you need to secure the trust anchor in a secure way. So that's not really an easy way. The easiest way just to really move the risk to a third party. So for that, you can query an external resolver and introduce in the RFC 3655, we have not the ED flag. So with the ED flag, you know that DNSSEC is validated. It's not just present, but it's also really valid. So basically the whole chain was verified by this third party. So just to summarize for the less technical part of the audience, we have the first party, so you do everything yourself. It is the most secure, but not the most usable. To have the most usable, you need to use a third party, so ask somebody else. So as an example of a third party, I picked Cloudflare, and I know there is some Cloudflare people in the call. So thanks to them, we have REST API we can call with this URL, cloudflare-dns.com, with a domain name. And you can see from the result that the AD flag is set for the icann.org domain, and we can do that basically for every domain that exists. So with Internet Society Chapter Belgium, we have developed a tool called Istrust that includes this really easy access via the Cloudflare API. So as you can see on the screen, I've put two big examples, but maybe first to clarify what is Istrust. Istrust, the idea is really to have all the information present for the user in just one click, to choose for him if a domain is trustworthy or not. So in this example, you have icann.org. There is a lot of really good information put by the extension by the tool. So you can see that the organization is verified. This is taken from the TLS SSL certificates. We know that it's registered in the name of Internet Corporation for assigned name and numbers, and from the United States, registered 27 years ago. But also the information about DNSSEC, so we can see that it's protected by DNSSEC. Compared to the other one, with Kraken.com that I just put as an example. So it's basically for the people that don't know this website, it's like a crypto exchange, but a quite old one. As you can see, it was registered 26 years ago. But there is not a lot of good information really, because we don't know who is owning the domain. It's registered in Iceland, and I never visited the website, so there is not enough history for the tool to really know if it's trustworthy or not. But thanks to DNSSEC, we know that if we're going to the kraken.com domain, we will go to the right destination, and there is no hijacking in place. So what really differentiates this tool? So the first part is that it's free forever. So it's basically financed and just running on a really low budget by Internet Society Chapter Belgium, because we believe that online safety should be a right and not a luxury. It's kind of the motto behind also the organization. The second thing is also it's fully transparent. So the code is simple. It's 100% open source, and you can audit everything or contribute on GitHub. So pull requests are really welcome for the most technical part of the audience. And the last part is the privacy by design. So basically, we have no server running. So everything is made from the end user browser. So it's the browser that is making all the requests to all the internet infrastructure, but without any man in the middle or somebody going from our side taking information. So just to close this speak, this tool is available in two big versions. So you have the online version when you can just go to istrust.org and you have access to most of the information through the web browser. So we can really bookmark the websites, but also available in all of the bigger browser as an extension. So we can install it easily in just one click. So I may have some time left. So maybe someone from the chat has a question, can answer it right now.
Yeah. Thank you very much, Julien, for this presentation about Istrust. So I can engage everyone after this meeting to install the browser add-on. But we can keep all the questions also at the end. So we have open micro. There are also a lot of discussions in the chat about the statistics, how much percentage of DNSSEC is implemented, that we can discuss afterwards. And now the place for the second part with moderator Natalia Filina. It's about driving the implementation of DNSSEC with a lot of different actors. Natalia, the floor is yours.
Thank you very much, Frederick. I'm Secretary of Uralo, and I'm very happy to go to the very practical part of our roundtable. And I would love to thank all of our speakers for the first very interactive and interesting part. And I would love now to ask the community experts about the joy and challenges of implementing of DNSSEC. And we have today Barbara Janssen. Barbara, you are a project communicator for the German nonprofit organization and project DSSEC, supported by the ICANN grant program. So my congratulations at first, that's great. Barbara, you will provide the outline of the section and you will open it. So please take the floor.
So my name is Barbara Jansen. I work with DSEC, like Natalia already said, in the project focusing on DNSSEC automation. That's what Peter also already said. And we were aiming to raise DNSSEC's accessibility and operability and thereby foster deployment. Turns out the beauty of automation alone will not get us there. Why? Why? Because DNSSEC has a serious image problem. Specifically, it is perceived as outdated, expensive, complicated to implement and to use. It's supposed to cause outages. It's not what our customers want. Nobody uses it anyway, etc., etc. See, that's bad. Fact is, there have been some serious outage issues, mostly some 10, 15 years ago, with servers being unavailable, some repeatedly, some for a long time, because DNSSEC is a complex thing. And of course, there have been reactions to these outages in the tech community. Most notoriously, the IANIX list of DNSSEC outages and a ranting 2015 blog post called Against DNSSEC. Both became very influential and launched a long-lasting DNSSEC bashing trend. And while DNSSEC supporters grew vaguely depressed by all this, they still put themselves to work on improving the protocol technically, notably by automation, we've heard about it, and shared their progress. Just that by then, the community was already past listening, and DNSSEC's image remained unchanged. At that point, you might wonder, can some random web publications, even if echoed in the community, really have an impact on the actual deployment of a technology? Are people just going to decide to go for DNSSEC if they think fit? No. For one, those who decide on funds and companies usually are not the techies, but the managers. And of course, if presented with a budget request, the managers will go online. They will talk to people to check on this thing their techie is advocating. And what they read and hear then is crucial. Because obviously managers have plenty of pressing issues on their plate. So if something like DNSSEC comes across as complex or even complicated, or as something likely to put at risk a backbone infrastructure like the DNS, then it will rather get trashed immediately or take a free fall down the priority ladder to the items labeled, "We will tackle this when we will have a little bit of time on our hands," which they obviously never have and never will. That's not rocket science. It's just the way things go. In short, so yes, image impacts deployment. So for us, in our project at DSEC, the problem was manifold. To allow for a fresh assessment on DNSSEC's actual current worth, first we had to neutralize the negative and outdated discourse about it. Second, we had to overcome DNSSEC fatigue so that DNSSEC could become a hot topic again. And last but not least, we had to convey the feeling among former DNSSEC supporters, by now silent or even doubtful, that this fresh impulse to spread DNSSEC was worth their support. I am a trained teacher, schoolbook editor, and dramatic advisor, so my look on things is a bit different from, say, the average techie. So I thought of that problem in terms of story and came up with 3 to-dos. First, provide updated information about what DNSSEC does and doesn't, and how automation changes the game. Second, use humor as a way to engage with people's accumulated frustration regarding DNSSEC and vent it. And third, tackle the image issue explicitly by explaining the human dynamics that put DNSSEC in the corner and prevented the DNS community from actively following its evolution and objectively assessing its role. In my notes, which you will be able to access after our call, you will see what we have done so far to cover all these grounds. Most recently, an article in Circle ID, co-authored by Roy Ahrens from ICANN, just a few weeks ago, which gives a deeper diving analysis of the dynamics I have just sketched for you. So if you get curious, go ahead and read it. And whenever needed, use this article and the upcoming ones as an antidote against outdated and sweeping discourses that are still out there. That'll do for now, I think, in terms of image. I'll wrap up the session later. Thank you.
Thank you very much, Barbara. I love so much your warm input to this discussion. So now let's go to our guest speakers from country code top-level domains. And I would love to give the floor at first to Ole Schacher. Ole, please tell us what is happening within CCTLD of Switzerland. Thank you.
Greetings from Switzerland. I work at Switch, which is the registry for the Swiss CCTLD.ch, and I will talk a bit about the history of DNSSEC in .ch while you look at this beautiful mountain. This mountain is actually related to our DNSSEC history, which you will see shortly. Yeah, so I joined Switch pretty much exactly 10 years ago, and DNSSEC at the time when I started was a complete mystery to me. I did know about DNS, I had done some DNS before, but DNSSEC, I had never heard of it actually. But my colleagues at Switch, they were massive proponents for DNSSEC. They were also experts already. I had to learn very quickly, and I very quickly learned all the things that the others like Barbara just have said, that this stuff is complicated. And yeah, I had to get my head around it somehow. But also there was one thing, it's complicated. Nobody really knows how it works. But on the other hand, it's also the only thing that we have. Basically, the message was the core infrastructure DNS is not secure, and DNSSEC is the only thing that helps us protect this critical part of the internet infrastructure. So I, put my head into it. I tried to learn it, and I saw that, all the things that are in Barbara's article are true. Like the support was horrible, like registrars had horrible interfaces, which Peter also just showed us. Like it was really hard to do anything about it. And there was another problem that I saw is that we already heard it today as well, that DNSSEC is invisible. I saw in the chat that people are starting to compare it to HTTPS, but HTTPS, they had one big advantage over DNSSEC. They had the green lock. As soon as you had the HTTPS certificate, then everyone could see in their browser, this is a secure website, and you could brag about it. And with DNSSEC, we don't have bragging rights. So that was a problem to get like the message across. There is like no incentive to enable it because you can't stand there and say, look at my beautiful green lock. There is none. But we still wanted to somehow increase DNSSEC adoption, because when I started at Switch, our DNSSEC adoption was at roughly 0.5%. So 0.5% DNSSEC adoption, which is bad. We wanted to increase that, and we hoped that with automation, like that would be our savior. So can you please go to the next slides, where we can see that the beautiful mountain that you saw is actually the mountain of DNSSEC, because if you follow its ridge, it matches exactly the history of DNSSEC adoption in .ch. So you see, I started in 2016, then we were still, even a little bit before, we were very low. And then like nothing happened for a long time. By the way, if you want to see like the actual graph, the mountain is not perfect. The actual graph, you can find it on our nic.ch website. But what you can see is that in 2022, something has happened, and we had like a massive boost, and now we are the DNSSEC heroes, and we have more than half of our domains are DNSSEC secure. So what happened? Automation, right? Unfortunately, that's only half the truth, because when we enabled the DNSSEC automation that Peter showed earlier, that was actually in 2019 already. and the big spike came only in 2022. So the automation obviously was not enough. Yeah, that made me personally a bit sad, but I was hoping like just give them automation and they will follow, but that didn't work out. The only ones that really did this was Cloudflare at the time. Basically 99.9% of all domains that in CH that supported this DS automation were hosted at Cloudflare. So yeah, we had to think about how obviously automation is not the whole story. What can we do? And we had to add something else. And unfortunately, the story is just money. So in 21, I think we launched what is called the DNS Resilience Program, which basically encourages all registrars and DNS hosters to secure their domains. And how we do that, like we are in Switzerland, everything is related to money. If you have a secure domain, it gets cheaper. So every domain renewal is 1 franc less if your domain is correctly DNSSEC signed. And this actually helped. After that, like the adoption spiked massively, because for big hosters that it's actually quite a lot of money. So you could argue, why care about the automation? Obviously, it's the money that made the change. I would argue it only worked out because we already had the automation in place. So the automation is not enough, but you still need it, because once we launched the program, basically all the registrars and hosters, they could just flip the switch. Like the support in open source DNS servers was already great. You just had to change one configuration option and all your domains are automatically signed and DS is updated. So this gave the big spike. Yeah, to finish off now, we have, as I said, about almost 55% DNSSEC adoption. The resilience program actually has the goal to get to 60% by the end of 26. We are not sure if we're going to reach that. We feel like we are now at the point where basically everyone that wants to do automation is already doing it. Except for, I see we have people from Cloudflare here. I see Cloudflare still has a few .ch domains that are insecure. So if you want to flip the switch for them as well, then maybe we can reach the 60%. And with that, I think my 7 minutes are probably more than over. Thank you very much.
Thank you very much, Oli, for your story and for your pictures. And I think we can go to the Portugal pictures. Maybe we can see the Roca graphic. I don't know.
So quickly of the demo, this is the intermediate result, and then the next result will be in half an hour, which is why I'm injecting myself now. So I will quickly share my screen again. It will be only like half a minute. So you will see the domain is registered and does not have DNSSEC yet. Sharing my screen. Here you go. This is what we saw before. The domain was not yet registered. And if I update this, then you can see it is registered, but there is no DS record. And this is where the automation will kick in. And I'll talk to you again in half an hour.
Thanks, Peter, for this update. We can go now to the José Casinha, and we will look at the story of Portuguese country code top-level domain. Thank you.
Hello, everyone. Nice to be here. What we've been experiencing here in Portugal. So we've been already mentioned as one of the lower adoption countries in terms of DNSSEC. So in fact, the number is on a 3.1% of the total domains configured with DNSSEC. And the last year, 2025, we had a steady line and not an increased type of line that we were used to have in the previous years. And yeah, we've been talking here during this session about all of those situations related with DNSSEC, and confirms my point of view, which is DNSSEC lacks on branding, lacks on marketing, because everything that is required to be up and running an infrastructure on DNSSEC, it's all about the complete supply chain from the registry, the registrar, the owner of the domain, and finally the user. And the final users, they don't perceive that there's a DNSSEC involved, and so they do not experience the need somehow. If you look into the owners, It's one more pain that they have to have in their operational stuff, which is they need to keep the keys updated and everything running. Because if there's a fault, what user will see, it's a site not found, which is like a brutal image about the in-operational activity of a website. They don't see any type of incentives. The support teams on the registrars, they don't want to spend more time solving questions or problems or issues related with the DNSSEC type of malfunction because they want to automate as much as possible. And so the lack of knowledge on the owners of the domains and in the companies where they are operating related to the DNSSEC is still an issue. We see that there's a lack of knowledge about the protocol, how to implement, and also the fast pace of the technology adoption and all those motions that are already happening in the companies. They are forced to be much more on the top of their mind, which is not. In fact, DNSSEC, it's not a thing. I used to compare DNSSEC with the reverse configuration. So there's lots of DNS records that don't have a reverse configured. So it's like the same. It's just working. So let's go on. Let's move on. And then the reverse is not configured. So the DNSSEC is not configured. So those are similar problems at the mindset of the technical guys over the companies, because the management don't know about this. This is just technical things, right? Or otherwise you have a kind of a technical manager worried about that and the implications that are behind that. You are pushing to have those configurations up and running. Otherwise, they would not be visible at the management board, right? So this is a topic. Again, this is an airbag, of course, but the airbag to be correctly implemented needs to be very well adopted, at least for the supply chain. And then when you see the registry, the registrar, and the owners, they have to have at least, let's say, a common ground whenever we are talking about the DNSSEC, because we cannot rely on the user, because the user just assumes that it's there, and if anything happens, someone will fix it. But at the moment, what I can see here, and looking into the numbers that we have by sector on the adoption of the DNSSEC in Portugal, we can see like the majority of the adoption, which is not so high, is on the utilities. So like this kind of companies related with utilities, including telecommunications and research and development companies. Those are the ones that are mainly adopting DNSSEC. But the fact is, they are not the heavy users of domains, because all the small and medium business companies, which have their own domains, which are the majority of the domains in Portugal, they don't have technical expertise to have that kind of conversation with anyone, right? So they need to rely on someone to build this and to configure this on their behalf, right? So this is a pain for, let's say, for the small and medium company, which is not technically, let's say, equipped to do that. We have a tool which is publicly available. We call it webcheck.pt, where anyone can evaluate what is the security posture of their domain. Then they can see if the DNSSEC is well configured, PF, DKIM, DMARC, all of those attributes. And then we have numbers about the percentage of domains that are very well configured. And then we have a kind of a stack rank and analysis about the posture of the zone. And then just for comparison, so we can see that 59% of the domains have SPF configured. But on the other hand, only 36 have DKIM configured, right? In terms of email. And then why this adoption is higher? Because here we are fighting and with a topic that is well understood, which is the spam email and all of those, let's say, attempts to send emails on behalf of someone or something like that. And so I think DNSSEC needs to have image consultant working on this topic to create a sound, beauty, let's say, story about the use of DNSSEC. And these multiple stakeholders that are required to have the topic up and running, they need to, let's say, make this consortium on language and on benefits and the needs to have this implemented. Of course, if we go to the incentives of a €1 or €1 discount to promote the adoption, of course, that is a good incentive. But again, at least for us, this is a very low margin type of service that we as a registry, we cannot go below what we have already, because we know that the registrars are selling our service with a very high price market on top, so there needs to be also a joint conversation between, from one side, the registry that want to populate and to put the awareness of this topic as a priority. But on the other hand, we have to create some type of incentive to have these registrars, at least the bigger ones, doing their job on our behalf somehow. Because we don't have any type of voice to force the user to amplify their requests, because there is nothing that they can see or they perceive as valuable to argue. And so this is a dog and cat type of fight that we have here. What we have in Portugal, a strong tail of small and medium companies, right? Very long tail on small companies, lack of knowledge and lack of visibility of the benefits of this protocol. That's the reason why we are not able to spread our word and amplify our voice on this topic, right? This is our experience that we have in Portugal.
Thank you very much, Jose. And I think we maybe in the future may go beyond of the European region, because now we are within EURALO, and we might invite to such conversation other CCTLDs for exchange. Thanks a lot. Now, I would love to give the floor to Werner Staub from the CORE Association, a non-profit membership association of registrars and registries. And I may say that, Werner, we expect you provide a consolidated bunch of points of view from registries and registrars regarding DNSSEC. So please take the floor.
Okay, thank you very much. It's, of course, important to talk about this subject of automating DNSSEC and also the making it understood in the public, because the actual beneficiaries of its use are not necessarily just, or not primarily actually, the users who activate it. The public at large is the beneficiary, because for bad stuff, it is, of course, easy if not everybody follows best practices. And it would certainly be a situation where we could say DNSSEC is part of best practices, and thanks to automation and the efforts that people here in this community are making, it is becoming something that can just be activated and people can be assured that they're doing the right thing. Now, a short note about CORE Association. CORE Association runs registries. It has a subsidiary called CoreHub that does registrar services, so it connects registrars to, or resellers to, it is a registrar that connects resellers to registries. So we've got experience on both sides with DNSSEC. We implemented it on both sides in a number of ways. And one of the things that, of course, that we have to specifically be careful about is that what we do in GTLDs has to be standardized, and ICANN was looking at that aspect as a particular additional requirement above and beyond just the practice of improving DNSSEC. ICANN wanted to be sure that there would be an appropriate handling of DNSSEC automation once this was possible. We implemented it for DOTS. This is one of our customers, so the Federal Office for Communications is the registry operator, actually for the confederation itself, of .Swiss. We do the technical stuff for it. And in order to be at the same level as CH, we activated DNSSEC automation, what we called child DNS key, on .Swiss, but were then told by ICANN to deactivate it. And the reason was that ICANN observed that a couple of clarifications needed to be in the standard, and this took, of course, its time. This is now, I believe, almost complete. And then secondly, ICANN wanted to be sure that special cases that have also been standardized in the GTLD realm would also be handled in a standardized way. Peter already mentioned that, how the entire logic would behave in the case of a lock. That should be ideally the same, or it would cause problems if people had different behaviors about that, because that standardization is expected in the case of GTLDs. So the latest situation is that ICANN has promised to create a template that would probably be ready later this year, that would then could be requested by registry operators such as .Swiss. And so the .Swiss could actually then reach the same level of DNSSEC automation as what has been done for .ch. Of course, as José has also mentioned, working on the price as an incentive is not necessarily open to all operators. I can, for instance, give a totally different reason why this is not so easy in the case of .Swiss. .Swiss has a price that is actually defined by public service pricing, because the government itself is the service provider. So they cannot so easily just update the price, even if there's a good technical reason to do that. Finally, I think it's worth saying why we want to do this. We've had introduced other ways of automation that are okay as well, but they depend on other solutions in place, such as sending all the requests through a certain channel, or having a name service provider that is the same as the registrar, which of course creates new complications in that logic. So the approach that has been taken for DNSSEC automation, which allows the discovery of the appropriate keys to come from whichever operator wants to participate in doing that, just like what Peter is in the process of demonstrating, is a good way of automating. And there's the other aspect of HostGaze, people might underestimate how important automation is. It might look, it's just more comfortable. It is actually not just that, because if it is not automated, it will actually take time and stress of people who literally have other things to do, because it cannot easily be done by a person who just does this on the side and has no particular training. And even more importantly, usually if it is not automated, it requires people, even if they have to do this kind of as a boring activity requiring all their capabilities, above and beyond that, it requires a powerful password, which is not a good situation to have. You don't want to have situations where access with powerful passwords for things that are routine and keep being required of people. They should be able to go about their important activities and not be bogged down by that kind of activity. So automation is really important. It should be the basis on which we build things. And it is, of course, once we have that under the roof, also a step further in the direction of what we've heard about other attestations and knowledge about the trustworthiness of domain name. There's a whole list of things to do to be sure that a domain name can be trusted and is not just good for the users or their owners in their own right, but also a good citizen in the internet itself, not being, unfortunately, something that happens, a way to make bad business decisions or bad design a habit, and then people think we just do this because everybody does it that way, so we keep it that way too. So the more we go into the right direction, the less we're going to have to deal with that kind of problem. Thank you.
Thank you very much, Werner. Another great input. I think we will have a big set of action items for our community after this roundtable. So now I will give the floor to Christian Elmeroth from Cloudflare. Christian, you promised to draw a beautiful picture of joint dance of DNSSEC. So please take the floor.
Thank you. We're slightly over time according to the schedule, I believe. So I will try to be fairly short, but not speak too fast. Anyway, I'm Christian Elmeroth. I work as the engineering manager for the authoritative DNS here at Cloudflare. And the C word has been said a couple of times already, both in comments and during the sessions. It hasn't been said clearly enough, but I would say DNSSEC is unique compared to other security technologies that we use on the internet. Not through the chain of trust, but while that is an integral aspect of the whole technologies, the important portion is that it actually protects the integrity of objects at rest as well as in transfer. That is, when I say at rest, I mean in cache on a disk, or in memory for that matter. And that means that the integrity of the object can be verified and content validated at any time, as long as you have a chain of trust that you can verify all the way up to it. And this is an aspect of DNSSEC that has not been pointed out clearly enough. And because of this, DNSSEC can serve as a foundation for other technologies as well. So yes, DNSSEC is complicated, but also it's not. Is that confusing? Slightly. Let me rephrase it like this. DNSSEC gets complicated when you look at the details. Denial of existence, for instance, trying to show NSEC3 chains. I can go into all kinds of technical issues. But the core DNSSEC with DS records, DNS keys, and RSIGs is actually quite understandable. And another thing is, DNSSEC is not about privacy. It's not about private DNS. DNS is public information, period. And that means anything you put in DNS is publicly accessible. So when we come to looking at why hasn't DNSSEC been implemented at a larger scale across a wider zone, you have the chain of trust, and that also slightly creates a problem. You need to put the DS record in the parent zone to secure the DNS keys in the child. For instance, the top-level domain hosted DS records for example.com's DNS keys. So when the owner of DNS of example.com decides to sign the zone, it needs to get the DS record put in the parent zone. Typically, as been pointed out several times, this is done by the registrar. It typically involves, for the majority of all the TLDs out there, requires a zone owner involvement. Beyond, even if they use an operator like Cloudflare, where they can simply enable DNSSEC with a one-click, or they use a registrar which has a one-click, there is some involvement beyond the simple enablement of DNSSEC. And more importantly, a DNS operator is typically outside of the RRR model, where you have the registrar and the registry. And we cannot change the DNS keys without involving customers. For instance, regular rolling of DNS keys is problematic. Now, I'm not saying one should necessarily perform regular rolling of DNS keys. There are really only two valid reasons why one would do that. None of them really involve security, unless, of course, a key has been compromised. So, while that is a problem, what about securing child zones? Childexample.com, all of that is up to the owner typically. As has been said, automation comes to the rescue. We have CDNS key records in the child zone to signal intent. And when I talk about this further on, when I say CDNS key, they are essentially fulfill the same purpose, but there are subtle differences. We do have automated protocols for performing DNS scanning, which is essentially a pulling mechanism. We also have the potential for secure bootstrapping. RFC 9615 has been mentioned. And RFC 9615, which Peter is a co-author to, it uses provider name servers and requires them to be secured during DNSSEC. But that has actually the beautiful benefit that even enabling DNSSEC automatically can happen in a secure manner. And the best part of everything, DNSSEC automation works for child zones too, assuming that you have a DNS operator that supports DNS scanning. Now, what is the problem with performing CDS scanning? It has a very low signal to noise ratio. And when I say that, you can scan millions and millions of zones, you either find no CDS record, or you find one because they use potentially Cloudflare, or you found no changes. That is, you perform a lot of scanning work to pick up no changes. There is ongoing work to improve this in the IETF, but for now, let's say, given the low proportions of TLDs that support CDS scanning or DNS operators that support CDS scanning. It's a few steps out of the way for now. Now, Cloudflare, if you enable DNSSEC, we fully support creating CDS records by default. It happens without user automation. And we also, by default, supports the standard of putting the CDS records on our name service zones, which is RFC 9615. And we are very strong proponents for more TLDs, other operators performing some sort, at least at this stage, performing some sort of CDS scanning. So what is the current status of DNSSEC automation? Unfortunately, very few TLDs support CDS scanning or other forms of DNSSEC automation. And even worse, very few registrars support CDS scanning. And not a whole lot of operators support CDS scanning. And when I say DNS operators, I'm mainly talking about child zones, where you delegate a child zone to another provider, where one operator would then be able to perform CDS scanning of the child zones. But what about multi-provider DNSSEC, or as referred to, multi-signer? That's an area where we don't yet have the full automation picture. There is ongoing work. We are trying to make this simple as well, so that when operators will be able to roll DNSSEC keys, and the DS records would be and zone signing keys will be automatically synchronized in between the different operators. And I would like to mention another thing. While we're talking about automation, there is automation for name server updates. It's called csync, this record type. And even fewer TLDs actually support that. As a DNS operator, it's very frustrating having to ask a customer who's actually delegated the responsibility for providing DNS and DNSSEC for their zone. They enable DNS, they add a DS record, fully securing the zone, and yet if we have to make a chain, then we need to involve the customer rather than relying on the trust that they put in us. We would like this to be much simpler for everyone involved. And by making it simpler, it will also by nature be more robust than what it currently is today. I'm here for questions afterwards, so thank you very much.
Thank you very much, Christian. We have not so much time, but we have a lot of questions and exchanging in chat. So now, Barbara, I'm giving the floor for you for 1 short minute for wrapping this session.
Very short regarding all the aspects that have been mentioned here. What I retain, I would like to start with what said Kavi in the chat. Yes, you're absolutely right. DNSSEC is not a religion. There have been a lot of missionary statements in the past. And there have been a lot of mistakes also in trying to get people to use DNSSEC who hadn't either the infrastructure or the technical knowledge to do it. And so this caused a lot of harm. Our way to tackle things is more that for people who make the informed decision to use DNSSEC, this should be available and as easily available as possible. So the target isn't 100%, it's just 100% of people wanting to have it should be able to have it. Because real choice relies on knowledge and availability. That's the thing. So we heard about automation was good to achieve that. There should be actors allowing for the use of DNSSEC. There can be money incentives. We need an image consultant. No, I just think we need to reclaim the story a bit and to make it in more balanced, to tell it in a more balanced way. And what can Uralo do to do this? It can spread the information. And it can weigh in when the time comes that I can start its policy process to say, yeah, we are in support of gTLDs getting automation, because I remind you that there is this megalodon.com with more than 100 million domains that can use automation. And it would be great if they could. So I think you can make a difference. Thank you very much.
Thank you very much, Barbara. Fully agree with you, and such a great conversation today. I'm so sorry we have not so much time, but we have still a time for the open microphone. Maybe someone would love to take the floor for some comments or question. And I may say that all of your chat conversation will be posted on Wiki page and will be open for everyone. So you may use these ideas or exchange for further collaboration or discussion. Now, if someone would love to take the floor. I don't see any raised hand. So, Frederick, I think we can go to the conclusion part.
Yeah, I've seen a lot of remarks from, I don't know how to pronounce, Kevin. Maybe he wants to say something because there were a lot of different things. If he wants to summarize in a few minutes.
Hello, everyone. No, not much. I was just listening and enjoying. Thank you. And I had my comments, but very useful, very informative. I just wanted to say the technology, I was very much for DNSSEC. I was working for IPNCC. I was ICANN board for 6 years, active at ICANN for more than 10 years. But what I can say is a lot, we have fought a lot for DNSSEC, but I think if a technology is not adopted after 21 years by the community, with all the push, I mean, there are millions and millions spent in and not only promotion, even running, think about the key ceremonies ICANN runs. It's all community money, and the protocol hasn't picked up. And the pickup we have is actually by a few major providers which enable it as an option, and a lot of people just enable it. Just look at the top providers like Cloudflare, and you will see why there's a huge jump. Without those, there was even a lot less. A technology which is alive by our push, I'm not sure if we should fight for it that much. After 21 years, I give up, and I think we have to have a solution. There were some very right comments that it should support the distributed nature of the database, of course, which is very complex. But until we get there, I have no solution. But I just want us to, at least personally, I just wanted to mention that I have stopped promoting DNSSEC. I have nothing against it. I won't stop people, but I think there should be some thoughts going into that before just saying, oh, another good thing, let's enable it. I would not suggest that. Thank you.
Thank you. And see the hand raised from Lutz Donnerhacker, and you had some good ideas also in the chat. Lutz, please.
Lutz Donnerhacker for the record. Having 21 years of deployment and no 100% success is not an issue. DNSSEC is as old as IPv6, and we have a better adoption in DNSSEC than in IPv6. If we are saying, if we do not have an immediate success, we drop everything, we will never come to an end and never get an improvement. DNSSEC has a purpose, it serves this purpose, and we can continue doing it with work. And please stop overloading it with expectations which can't be fulfilled. Thank you.
Thank you very much, Lutz, for your comment. It was indeed also something I wanted to mention. The IPv6, when I was student, was the future, and I'm not close to be student now. Just kidding. Yeah, so to make a wrap up, I would like already to summarize as closing remark. So the first thing is with DNSSEC, there is a big added value, it's there, but there is first a lack of knowledge of DNSSEC, and that is also one of the purpose of this roundtable. And also to come with resources afterwards. So do not hesitate to come with questions and to reach out to all experts we have in the network. The second thing is the visibility. It's like the airbag, it's there, but you don't know. If you don't know, we should maybe work to improve the visibility. It's one of the ideas of the ISTrust project to make that visible also to end users in the browser. But there are other leverage we can have too, because this is really something needed and useful. The third thing is about the support, and especially there, the automation could help, but it's also linked to the lack of knowledge and investment, and we should have more automation to have the DNSSEC implemented just in a click. And you have a lot of, not a lot, you have some register doing that, but not all. and also end users, the domain owners are not aware of what it is. So it's really a mix of everything that could lead to have more security, and that's really the purpose. Just remember, if there is no DNSSEC, I can have a domain name, I go to this URL, and I could be, someone can give me a fake IP address, and I would redirect to something random, criminal, or whatever. It's sometimes a joke I'm doing myself. I go to the host file, I just do that, and oh, my site has been hacked. No, it's just the DNS. It's also how governments are using DNS to stop some websites, or to redirect some websites to government, how to say that, controlled websites. So it's really something we really needed. So yeah, it's just a first step, thank you everyone for your participation, for all your comments. The comments will be published also on the wiki page of the event. Do not hesitate to participate to survey. You will receive a survey afterwards. What was really good in this meeting? What could we improve? And do not hesitate also to reach us to us if you want to be in contact with some experts, if you are blocked by something, because we want to promote really the DNSSEC, really useful, even if it's quite complex, but we need to invest. It's an investment in security, good for everyone. So I would like to thank everyone participating, all the speakers. Thank you, really great. And I'm wishing you a good rest of the day or the night. Thank you.